Okay, section 8.4 is on scale factors and areas of 2D shapes. So we're going to look at first this rectangle and calculate the area of the rectangle with a side length of 6 centimeters and a width of 4 centimeters. So the area would be length times width, which is 6 times 4, or 24 centimeters squared. Because the area of a rectangle is length times width. So now if we consider a scale factor of 2, our new length would be the new length, would be 6 times 2, which is 12 centimeters. Our new width would be 4 times 2, which is 8 centimeters, which means our new area, which is length times width, would be 12 times 8, or 96 centimeters squared. So if we take the area of the image, which is 96 centimeters squared, over the area of the original, which was 24 centimeters squared, that's equal to 4. If we take a scale factor of 3 and apply it to the length, we get a length of 6 times 3 is 18. And the width would be 4 times 3, which is 12. So therefore, the new area would be 18 times 12, which is 216 centimeters squared. And if we take the area of the image, which is 216 centimeters squared, over the area of the original, which is 24 centimeters squared, we find that that equals 9. And the last one, if we take the length, is 6 times 0.5. We get a length of 3 centimeters. And the width is 4 times 0.5, would be 2 centimeters, which gives you an area of 3 times 2, or 6 centimeters squared, which if we take the new image over the original, that reduces to 1/4. So if we look at each of these ratios of area of image over area of rectangle, you should notice that it's connected to your scale factor. If you look back and kind of look at this number here, compare that ratio that we have of area of image over area of original, and compare it to the scale factor, notice that 4 is actually 2 squared, and that 9 is actually the scale factor of 3 squared, and 1/4 is actually the scale factor of 1/2 squared. Half is the same as 0.5. So when we're asking the next question there, how does this area of the rectangle change when it's enlarged or reduced by a particular scale factor, we really don't see this. It's not like what we did in the lengths, that it's not the scale factor times the length. When you're looking at comparing areas, it's actually the scale factor squared times the original area. That would give you the area of the image. For example, if you look back at the example with the scale factor of 2, the area was not doubled the original area, but it quadrupled. So that leaves us to this formula: k squared is area of image over area of original shape. And you can cross multiply that, or multiply both sides by the area of the original shape, to end up with this equation, that the area of the image, if you think of it as like k squared over 1, equals area of image over area of original then if you cross multiply that, you'll end up with this equation here, that the area of the image is equal to k squared times the area of the original shape. So let's try some examples now with this new formula. It says a 3-inch by 4-inch picture frame has dimensions that have been tripled. So that means the scale factor is 3 if the dimensions are tripled. What is the area of the new frame? So if we use our formula, k squared equals area of image over area of original or the other version, which would probably be even better, that the area of the image equals k squared times the area of the original. So we're looking for the area of the new frame. We know that the k is 3, so it would be 3 squared times the area of the original would be 3 times 4, or 12. So that would be 9 times 12, or 108 inches squared. In the next example, Charlene and Chad painted a mural on the wall measuring 12 feet by 8 feet using an overhead projector. If the original sketch had an area of 216 inches squared, what is the scale factor? So in this problem, we'd be better off using the k squared equals area of image over area of original. So we don't know what the scale factor is, that's what we're trying to find, so k squared. And the area of the image, now in this case here we've got two different units, one is inches and the other one is in feet, so you might want to change them both to the same dimensions, same unit for dimensions. So this one I would take, there's one foot is equivalent to 12 inches, so that means 12 feet would be 12 times 12, or 144 inches, and 8 feet would be 12 times 8, or 96 inches. So therefore the area of the mural in inches squared would be 144 by 96. Now you could also convert the inches squared back to feet squared, but you got to be careful because it's inches squared, so it's easier to do the linear measure of foot than take the area measure of inches squared and convert units. So that's why I went and changed both things to inches. So 144 times 96. Because it doesn't matter if they're in inches or in feet so long as they're both in the same units, as you are doing a ratio. So this here, I would know that k squared would be 13,824 would be the image, and the original would be 216. So k squared would equal that divided by 216, which is 64. So k would equal the square root of 64, which is 8. So the scale factor would be 8. The image is 8 times, the dimensions, I guess, are 8 times larger than what the original dimensions were. Okay, question number 3. Jasmine is making a kite from a 2 to 25 scale diagram. So when you have 2 to 25, that means that our k is 2 over 25. The area of the diagram is 20 centimeters squared. How much fabric will she need for her kite? So, if we have k squared equals area of image over area of original, then in this case here, our original is our kite, because we know that if we're using a scale factor of 2 to 25, that means we're reducing. So our diagram is actually going to be the smaller thing. Your diagram is going to be your image. So our k squared should equal, we can replace the k squared actually with what we know k is. K is 2 over 25. So that squared equals the area of the image, which in this case is 20, over the original would be x, because we know that the image is going to be smaller than the original, which was the actual kite. So we know that the smaller number should be in the top of the fraction. The bigger one, which would be the actual kite, would be in the bottom to get a k scale factor that's smaller than 1. So we've got 2 over 25, which is going to be 2 times 2 is 4, over 25 times 25 is 625, sorry. Equals 20 over x, and then you can cross multiply and get 4x equals 20 times 625, which is 4x equals 12,500, and then x would just be divide both sides by 4. So x would be 3,125 centimeters squared of fabric is needed. So these are some practice questions now. Jim's laptop has a monitor with dimensions 9 by 12. The image on his laptop is projected onto the screen of a whiteboard. According to the documentation for the whiteboard, the screen area is 2,836.6875 inches squared. So the image on the whiteboard is similar to the image on the laptop. So it's determined the scale factor used to project the images on the laptop to the whiteboard. So this would be a k squared problem again, equals area of image over area of original. And we're looking for the scale factor, so we don't know what that is, but we know that k squared equals the area of the image, which in this case is 2836.6875 inches squared over the area of the monitor image, which is the original. I'm just going to work that out up here. 9 times 12 is 108 inches squared. That's a multiplication sign there. And that would give us k squared equals that, which if I divide those two, 2,836.6875 divided by 108, I get 26.2656. So k is equal to the square root of that. Is 5.125. So the scale factor, that would be your scale factor. So basically the dimensions on the whiteboard will be about 5 times as big as the dimensions on your monitor. To determine the dimensions of the whiteboard, so that means that the new width would be equal to the k, the scale factor, times the original. So in this case here, the scale factor was 5.125 times the original width was 9. So that would be 5.125 times 9, which is 46.125 inches. And the new length would be the scale factor, 5.125 times the old length, which would be 12. 61.5 inches. Parallelogram has an area of 42 centimeters squared. It's going to be enlarged by a scale factor of 5. And it says determine the area of the enlarged parallelogram. So again, if we use our formula, k squared equals area of image over area of original. We end up with k is 5. We can fill that in. 5 squared equals area of image, we don't know, but we do know that the original has an area of 42. So that means 25 equals x over 42. And that's the same as 25 over 1, so we can cross multiply that and get x is 25 times 42, which is 1050, and that x represents the area, so the inches squared, or centimeters, sorry, not inches. Centimeters squared, because it has to be the same units as the original. So it would be centimeters squared, the new parallelogram, which is enlarged, so that does make sense that it's larger than the original of 42. And it should be 5 squared times large. So there's some questions there, I think, at the bottom. Oh, no, not for this section. They're listed on the next section. Okay.